Chapter 2, Thermochemistry. In this chapter, we will study the relationship between chemical reactions and energy changes that involve heat. There are 4 subtopics in this chapter: 2.1 Concept of Enthalpy, 2.2 Calorimetry, 2.3 Hess's Law, and 2.4 Born-Haber Cycle. 2.1 Concept of Enthalpy. The learning outcomes are: A. Explain endothermic and exothermic reactions using the complete energy profile diagram. B. State standard conditions of reactions and define the following terms: enthalpy and standard enthalpy. Energy. Energy is capacity to do work. The units of energy: for SI unit, the unit is joule. 1 joule equal to 1 Newton meter or 1 kg meter square per second square. For non-SI unit, 1 calorie equal to 4.184 joule. The energy change in a chemical reaction can be represented using energy profile diagram. There are 2 types of chemical reactions: exothermic reactions and endothermic reactions. Exothermic reactions. If a reaction is exothermic reactions, that is, heat is given out to the surrounding. Delta H is equal to sum enthalpy of products minus sum enthalpy of reactants. The enthalpy change of the reactions or heat of reactions delta H has a negative value because the heat contents of the products is less than the heat contents of the reactants. Example: combustions, neutralization. 2H2 plus O2 gas produce 2H2O liquid. Delta H is negative. HCl aqueous plus NaOH aqueous produce NaCl aqueous plus H2O liquid. Delta H is also negative. Means both reaction, combustion and neutralizations are exothermic reactions. Energy profile diagram for exothermic reactions. Y-axis is enthalpy, x-axis is reaction progress. Since for exothermic reactions, the delta H negative means enthalpy of reactants is higher than enthalpy of products. Difference reactants to peak is EA, activation energy, and difference between reactants to product is enthalpy, delta H. Okay, look at example 1. Consider the following reactions. 2H2 plus N2 gas produce 2NH3 gas. Delta H is negative. Draw the energy profile diagram. Since given delta H is negative, means the reaction is exothermic. Okay, answer. We have reaction between 2H2 gas plus N2 gas produce 2NH3 gas. Delta H is equal to negative. Okay, so as usual, y-axis is enthalpy and x-axis is reactions progress. For exothermic, enthalpy of product is less than enthalpy of reactant. So this one is reactant, this one is product. However, since we already know the species of reactants is H2 and N2, so write the reactant species as 2H2 gas plus N2 gas, and the product species is 2NH3. Okay, then label Ea and delta H negative. Endothermic reactions. If the reaction is endothermic, that is, heat is absorbed from the surroundings. Delta H is equal to sum of enthalpy products minus sum of enthalpy reactants. The enthalpy change of the reactions delta H has a positive value because the heat contents of the products is higher than the heat contents of the reactants. Examples: ice melting and vaporization. So H2O solid change to H2O liquid, delta H positive, and H2O liquid change to H2O gas, delta H is also positive. Energy profile diagram for endothermic reactions. Y-axis is energy and x-axis is reaction progress. Endothermic reactions means enthalpy of product higher than enthalpy of reactants. Label Ea, reactants to peak, and product difference between reactants and product, positive value. Look at example 2. Consider the following reactions. H2O solid produce H2O liquid, delta H positive. Draw the energy profile diagram. Okay, we have H2O solid change to H2O liquid. Delta H is positive. Okay. X-axis is reaction progress and Y-axis is enthalpy. So endothermic ataupun positive value means enthalpy of product higher than enthalpy of reactant. So H2O solid as a reactant and H2O liquid as product. Then label Ea, activation energy, and delta H positive. Standard conditions. Enthalpy with symbol H is measure of the heat contents of a substance at constant pressure. The enthalpy measured at 25 degrees C or 298 Kelvin, 1 atm, and 1 molar for aqueous solution, known as the standard condition. Is termed standard enthalpy. Standard enthalpy. The symbol is H0. The enthalpy of reactions delta H is the difference between the enthalpies of the products and the enthalpies of the reactants. The formula is delta H equal to sum of enthalpy products minus sum of enthalpy reactants. Standard enthalpy delta H0 is enthalpy change measured at standard conditions 298 Kelvin, 1 atm. Example of standard state of pure substance: oxygen is O2 gas, hydrogen H2 gas, sodium Na solid, bromine Br2 liquid, water H2O liquid. Specify whether the substance exists as atoms or molecules and its states of matter.